Today, we're going to go under the hood of language AI. We're going to see how machines went from basically seeing our words as just a random jumble of letters to understanding and even generating language in a way that feels, well, almost human.
I mean, it really does feel like magic, right? You type in a question, and boom, this incredibly sophisticated, human-like answer just appears on your screen. But here's the thing, it's not magic. Not at all. It's actually the result of this amazing, decades-long journey of scientists and engineers solving one puzzle at a time. So let's dive right in. The path to the AI we have today, it wasn't some single giant leap. No way. It was a series of these crucial, foundational steps where every new idea was built right on top of the last one. We're going to walk through that entire journey, starting right at square one.
Okay, so the first, and I mean the most fundamental challenge was this. Language is for us, for humans. It's messy, it's full of nuance, context is everything. Computers, on the other hand, well, they only really speak one language, numbers. So how in the world do you build a bridge between those two worlds?
This is the question that kicked the whole thing off. Just imagine for a second that you're a computer. You see a sentence like, "My cat is cute." To you, that is just a completely meaningless string of characters. You need some kind of system, a process, to turn that messy text into a structured format that you can actually work with.
So the first logical thing to do is to just break the sentence apart. This process is called tokenization, and it's pretty simple. It just splits the text up by the spaces. So a whole sentence suddenly becomes this neat little list of individual words, or what AI researchers call tokens.
Okay, what's next? The machine takes all those tokens it just made, and it builds a master dictionary, a vocabulary. This list has every single unique word it knows, and it becomes the main reference point for everything that's about to happen next. And here is where the simple but really clever part comes in. For any sentence you give it, the computer just goes through its entire vocabulary and counts. How many times does the word cat show up? 1. How about the word that? 0. The result? You get a list of numbers, what's called a vector, that represents that sentence. And just like that, we've done it. We've turned words into numbers. This whole method is called bag of words. And you know what? The name is perfect, because it literally treats a sentence like a bag that you just toss words into. The order, the grammar, the meaning, all of it is just gone. So the dog chased the cat and the cat chased the dog look exactly the same to this model. That's a huge problem, right? And that, of course, leads us to the next big breakthrough.
So we've got numbers, but they're just basic counts. They don't capture any of the meaning of the words. So the next big quest for researchers was figuring out how to bake that meaning right into the numbers themselves. I mean, think about it. How can a list of numbers possibly know that the word king is related to queen, or that an apple is a kind of fruit? The answer was a brand new technique that would totally change language AI forever. For the first time, machines could start to get that words have relationships just like we understand them.
And that technique is called word embeddings. The best way to think about it is like a huge multi-dimensional map for language. Instead of just a simple count, every single word gets a rich list of numbers, a vector, that acts like a coordinate, a specific point on this map. And its position on that map is all about its meaning. So how does that even work? Well, by analyzing just massive amounts of text, we're talking books, articles, websites, the model learns which words tend to show up near each other. It then starts assigning scores for all these abstract properties. So a word like puppy might get a high score for is an animal and is young, while apple gets a high score for is a fruit. It's like a mathematical way of encoding a word's vibe.
And the result is absolutely incredible. On this conceptual map, words that have similar meanings just naturally group together. Cat, dog, and puppy are all hanging out in one neighborhood. Apple and banana are in another. For the very first time, we could actually measure how similar two words are just by calculating the distance between them. This was a massive leap forward.
But there was still a pretty big flaw in the system. A word like bank would have the exact same embedding, the same spot on the map, no matter how you used it. But we all know language is all about context. So the next big challenge was to make these number representations dynamic. Yeah, think about it, the bank of the river versus the financial bank. As humans, we get the difference instantly because we use all the surrounding words as clues. But a model using these static word embeddings, it just sees the word bank and gives it the exact same set of numbers every single time. So the question became, how could we teach a model to pay attention?
So how they solved this one?
with what is probably one of the most elegant and beautiful ideas in all of modern AI. It's called the attention mechanism, and it does exactly what it sounds like. It gives the model the ability to decide which other words in a sentence are the most important for understanding any specific word. You can literally think of it as giving the model a smart highlighter, letting it focus only on what matters most.
Check this out. This visualization shows attention in action during a translation task. See how when the model is generating the Dutch word ik, that bright square shows it's paying super high attention to the English word I. Then, when it gets to llamas, its attention totally shifts to the word llamas. It dynamically figures out the importance of every input word for every output word it creates. This was an absolute game changer. And this idea of attention was so powerful, so revolutionary, that a group of researchers at Google started wondering, what if that's all you need? What if you could build an entire AI architecture just based on this one single mechanism?
And that question led to this. In 2017, they published a paper with the incredibly bold title, Attention is All You Need, and it introduced a brand new model architecture called the Transformer. This is the paper that laid the groundwork for GPT, for ChatGPT, and for pretty much every single large language model we use today. You see, the key insight here was to just get rid of the old way of doing things, where models had to process words one by one in a slow sequence. Transformers can look at all the words in a sentence at the exact same time. By building the whole thing out of these attention mechanisms, they made a model that wasn't just more powerful, but was also massively parallelizable. And that meant you could train much, much bigger models on way more data than ever before.
So inside a transformer, you've got these stacked blocks of what's called self-attention. And this is where the model is just constantly comparing every single word in a sentence with every other word in that same sentence, building up this incredibly deep, rich, contextual understanding of the entire text. It's not just looking at the words next door, it's looking at the whole picture all at once.
So there you have it. From just counting words in a bag, to creating a map of meaning with embeddings, to dynamically weighing the context with attention, and then finally building an entire system around it with the transformer, these are the layers of innovation, the fundamental building blocks that are running inside the AI that you probably interact with every single day.
This whole journey, it just shows an incredible progression of human ingenuity and problem solving. We figured out how to get machines to understand our language. So the really fascinating question now is what comes next? What new abilities are just sitting around the corner? That's a story that is still being written.